Hello guys, and welcome to my new 8086 microprocessor programming video. Let's start with the palindrome program. Okay, this is the DOS simulator where we run 8086 microprocessor programs usually. Here is my entire code of palindromes. Okay, here I can explain you, but these comments are not visible, so let me go to text editor and show you the entire code. Okay, let's start with the code. Okay, initially I have declared data segment. Okay, and then I went for code segment. Okay, I'll tell you why I have initially written data segment. Why cannot we do just everything in code segment? Okay, see, what we have to do is we have to store a string first of all, and then we have to reverse the string, and then what we have to do is we have to compare both the reversed string and entered string, and we must come to a conclusion that whether these two are equal or not. That will say whether a string is palindrome or not. Okay, so first of all I need to access a string from the keyboard. That means user has to enter a word or a string. Okay, that has to be stored in memory location. First of all, whatever the registers which are in 8086 microprocessor, all the registers are of 16 bit. Okay, 16 bit. So if I want to enter a string, okay, a big string, let's say it is of 6 letters. If a string is of 6 letters, then this string cannot be stored in any of the registers because its size will be more than 16 bits, because each letter will have 8 bits of data. Okay, 8 bits of data. So 2 strings I can store at the maximum in a 16 bit register. So I cannot store a big string in a register. That's why I am going to store the string in memory location. Okay, memory location. That's why what I have to do is I have to access the memory location, and I have to store every value in this data segment. Okay, that's what I am doing. Okay, whatever I am doing in data segment is, first I am creating 2 messages. First message is to tell that string is palindrome. The second message says the string is not palindrome. These two are the messages which I have written. Okay, or both the messages have the size of bytes. Okay, and this 10,13 is for new line character. Okay, and then I am declaring 2 variables. Okay, inside this segment. This data is a name, and this can be anything, any name. Okay, and in this there are 2 variables, x and y. Okay, I will tell you why I have written that and why these things came. org3000h, this address, offset address, this is nothing but the offset address. This offset address is given because we have to access the data. That means we should know whether the entered string is stored in this location or not. That's why once, if we want to know whether it is stored or not, if we want to access the stored data, then we have to store it in a location which we can access. That's why I am writing 3000h. So when I type 3000h, ds 3000, it will show me what and all the values stored in that memory location. And this variable is created to store the entered string. Okay, this first variable, x variable, is created to store the entered string, and second variable is stored in different memory location, and this variable is created just to store the reversed string. Whenever I write something after semicolon, this semicolon, after semicolon, if I write something, this will be treated as a comment in microprocessor language. Okay, assembly language. Okay, then when I type data ends, this segment will be ended end segment. Okay, end segment. That's how this data segment is done. In data segment I have written 2 messages, and after that I have created 2 variables at 2 memory locations. Okay, you know why these 2 are created now. Okay, then we will go to the code segment. Okay, Why I have written assume CS code and DS data, I'll tell you. Assume is an assembler directive. Okay, this assembler directive, what it does is it will assign these names. Actually, these are names. You can change these names. You can change this as something, your name or some other name. These are names. But whenever I do this, this colon is a segment overriding operator. Okay, what it does is it will assign this logical segment, whatever the segment I have created. Whenever I type data segment, I am creating a logical segment with name data, a logical segment with name data. Here when I type code segment, I am creating a logical segment with name code. Okay, code. So when I write this, it won't actually create and actually assign. So that's why assume CS colon code and DS colon data, these are segment overriding operators. What these does is this assume will assign, this assume assembler directive will assign these logical segments, data and code, these logical segments into the physical existing segments. This is data segment which is physically existing in memory location. Okay, this data, it will assign this logical segment into this physical segment. Okay, and this will assign code, the segment, logical segment code into the physical segment, which is nothing but code segment in the memory location. Okay, then we will start with the program. Sorry for that. Here you have two instructions in the beginning. This is just to initialize your data segment. If you don't do this, if you don't initialize this, you will get some weird kind of codes in your after execution. And sometimes if you want to initialize some values, this question mark is written, you have to write this, or you have to write some value, because this variable has been created. And if you write question mark, it will accept whatever the values which are garbage values already present in X, it will take that as the value. Otherwise, if you want to store a specific value, then you have to write it as 10H, whatever the value you want to. Okay, for the time being, I am writing it as question mark, because I don't know what, for the time being, I don't know what user gonna type. Okay, let it be whatever already is. That's why I have to write question mark. So whatever the value stored, if I write 10H here, if I write 10H something like this, then this value has to be stored to the data segment. That is done just with these two instructions. If you go and see these two instructions, this will assign, first the data will be transferred to AX, and then AX will transfer it to the data segment register. Okay, data segment register, this is a segment register. Okay, it will initialize the data segment. Okay, but they move DS comma data, this data is not possible, because it is immediate data transfer, and for segment registers, particularly for segment registers, the immediate data transfer is not possible. You can try it out and you will get an error that immediate addressing is not possible for segment registers. Okay, and after that I have declared these two, LEASI comma, I have written these two, LEASI comma X and DI comma Y, just to load the effective address of X into SI. What is the effective address of X? I have declared effective address of X is 3000H and effective address of Y is 2000H, as I have declared above. Okay, these will be stored into this SI and DI. These are pointer registers. Actually, SI is the source index and DI is destination index register. These two are general purpose registers, pointer registers. Okay, then I have move CX comma 0000H. This is done because this CX register is to count the number of letters of the string which will be typed by the user. Okay, when user types some data or string, we should know how many letters he has typed, because we have to reverse the string and we have to compare two strings also. Whenever we are comparing, we will compare one letter by one. Okay, so what we should know is, we should know how many letters are there in that string. Okay, so that we have to count the number of letters, and we have to use this value of CL when we know that the value of CX will determine the loop count. Okay, that's why we are storing it in specifically CX, not in some other register. We can store it in some other register, but finally we have to transfer it to CX. Okay, now that is done. Why we are initializing is because if you don't initialize with 0 0 0, there may be some garbage value stored in CX, and that may be incremented when we increment like this. Okay, that may be increment is nothing but add plus 1. Okay, add 1. So that's why we are storing it with we are just initializing with 0, then directly it will go 0 plus 1, 0 plus 2, like that it will do. Okay, then we have this loop. This loop will do the job of taking in one entire string. Okay, it will take one string from the user into the memory. Okay, it will store it in memory location. How it will do, I'll tell you. Move AH, 01 and int21h. These two statements, these two will access one letter from the user. It will take one letter from the user. AH, 01 must be stored in H, and it will int21h. When I press this, it will take one letter from the user, and it will compare this letter with 0dh. This, whatever the letter is taken, it will be stored in only AL register. It is by default that it will be stored in AL register. So what I am doing is compare AL, 0dh. What is 0dh? 0dh is the ASCII value of enter key. What I am doing is I am checking whether the person, the user, pressed enter key or not. What I want to happen is when the person enters or presses enter key, I want to, it's a notification that he has already entered the string and he want to come out of the loop. He don't want to enter anything. That's what it indicates. So what I'm doing is I'm checking whether he has entered enter key or whether he has pressed enter key or not. Okay, when he presses enter key, these two will be equal, isn't it so? Sorry about that. These two will be equal. So if they are equal, jump equal, I have written jump equal skip. Okay, if these two are equal, this will skip these instructions and it will go directly here and it will not perform these two. Okay, so that's why I have written that. So if it is not equal, let's say I am pressing some other 6-letter value, the 6-letter string, I press something else, move si comma l, then next this will be false, so it will go to the next, this instruction will be false, so it will go to the next instruction, move si comma al. What it does is al, whatever the value stored in al which has been entered by the user, that will be stored in si. The si, the memory location pointed out by si. Okay, till now si is pointing to 3000h. As you can see, si is pointing to 3000h. Okay, so in 3000h memory location, first letter will be stored. Okay, after that increment si will be done, because when I do this for the second time, I don't want you to store at 3000h only. If I store it 3000h, whatever I have stored already, that will be overwritten. Okay, that I don't want to happen. I want it to go to the next memory location and store a new letter. Okay, that's why I am doing increment si, and then increment cl is to count the number of letters. So once I have taken one letter, so I am counting 1 here, 0 it was initially, now it will increment and it will make it as 1. Okay, again jump up because I want it to happen infinitely long, because user can enter anything, and how much long it may be, but it should not come out until user presses this enter key. So here it will be compiled, when he presses enter key it will directly come out, otherwise it should be continuously running. That's why jump up, this is a unconditional control transfer instruction, jump up. Okay, so whenever he presses some letter, it will go back again here, and again it will follow these instructions. Second letter will be taken in. If it compares it with enter key, again if it is not true, if it is not enter key he pressed, then it will be this word will be stored in the next memory location pointed out by SI. It will be for the time now it will be 3001H. Okay, for the next time it will be 3002H. But at the end of this loop, you see, at the end of this loop, what happens is, let it be 6-letter word or let it be 3-letter word. Okay, if it is a 3-letter word or a string, if it is a 3-letter string, first value will be stored at 3000H, second value will be stored at 3001H, and the third value will be stored at 3002H. Okay, but the value at the end of the loop will be 3003H. If you can see, we will just do it. We will track it. First letter will be taken, it will become 3001H. Okay, second letter will be taken, this will be 3002H. Third letter will be taken, 3003H. Okay, actually, but the third letter is stored in 3002H. Okay, but the SI is pointing to 3003H. Okay, this you remember, it will be useful later. Okay, increment CL I am doing and jump up. String reversal, when I go for string reversal, first two statements I have written decrement SI and push CX. Okay, why I am doing decrement SI is, just now I have told that it will be pointing to 3003H. Actually, my last letter of my 3-letter string was in 3002H. Okay, last letter of my 3-letter string was in 3002H, but my SI register is pointing to 3003H. I want it to point to last letter of my string, so I want it to decrement it by 1. Okay, that's how it is. And then this push CX is used because whenever I execute this entire loop, this is not the entire loop, here is the entire loop. If I execute this entire loop, what happens at the end of this loop, CX value will be 0. So I cannot use same value of CX here. That's why for this loop. So what I am doing is, I am storing value of CX into, I am copying this value into a stack segment. Again I am popping after, I am taking it back after execution of this loop. Okay, in this loop, as you can see, this is very simple. Okay, in this string reversal, what I am doing is, I am pointing to the last, as you know, now when I did decrement SI, I am pointing to the last letter of my string. I will copy this last letter of my string to this, I will copy this to a register first, then I will copy from register to this DI, because this from one memory location to another memory location, value cannot be, the contents of one memory location cannot be directly transferred to another memory location in 8086 microprocessor. This instruction will not work. Only instruction that can transfer data in one memory location to another memory location in 8086 Pentium 4 microprocessor is move S. Only that instruction can do. These instruction, move instruction, cannot do this kind of job. That's why we are transferring the value of SI into a register BL first, then BL register value will be stored into DI. But DI will be pointing to 2000H, which is nothing but the first memory location where I am going to store the value. Okay, the first memory location. Okay, so this is whatever the last letter of my word or the string will be stored into the first memory location. And again what I am doing, increment DI, because first memory location is over, the second memory location it has to go, and decrement SI because I was pointing to the last memory location of my, or last word of my string, and now what I have to do is, I have to point to the last but one letter of my string. Okay, that's what I am doing. That's why I am decrementing SI. Again I am looping it. How many letters are there? That many loops will be, that many times it will be repeated, and all the contents stored in the memory location 3000 onwards, that will be stored reversely into the memory location 2000 onwards. Okay, this will be done in this thing. This is string reversal. Once I have done with this, I'll do these two things. I'll tell you why I have done these things. These are initial steps for palindrome checking, and this is till here we are done with reversal of string. Okay, and this entire thing will do our palindrome job. Okay, first these two, it's very simple. Okay, first, why I have written these two things, because whenever I come out of this loop, okay, at the end of this loop, as I have told you here, if I consider 3-letter string, when it comes out, its value will be 3003H. Okay, but I wanted it to be 3002H. Similarly, here what happens is, when this di, when it comes out of this loop, this loop will be executed, and when it comes out of the loop instruction, what happens is, increment di will be continued actually. So if it is a 3-letter word, it has to be I wanted it to be 2002H, but it will be 2003H. And similarly, this decrement si will be done. I wanted it to be 3000H. I want it to be pointing to the first memory location of the stored string or entered string, but it will be pointing to 3000 minus 1H. This will be incremented by 1 extra. It will be decremented by 1 extra. Okay, this will be pointing to 3000. This will be pointing to 2003H. This will be pointing to 3000. 3000 minus 1, which is 2FFFH. Okay, this is the example which I am giving. It can be anything. For a 3-letter string, I am giving an example considering like 3003 and whatever 2003H or whatever. Okay, so that's why I want both SI and DI. See, what I am doing is in comparison, that nothing but checking palindrome or not, I have to compare each and every letters of both the strings stored. Okay, one is the enter string, another one is reverse string. I want to check both, each and every letter, compare letter by letter and check whether they are equal. So I need to point to the first letters of each word. That's why I am doing this again. When I do this LEA DI comma Y, it will go to 2000H. DI will point to 2000H, and LEA SI comma X will point to SI will point to 3000H. Okay, 2000 and 3000 are the first letters of both the reversed and entered string. Okay, then I'll pop CX because I'm going to execute a loop again. Okay, I have pushed here and I'm popping here. Before this loop I have pushed, after this loop I am popping. Okay, then in this loop my palindrome, whether to check whether it's palindrome or not, will happen. Okay, see, it's very simple. Again, what I am doing is, again I am transferring the value of the data content present in SI, which is nothing but in 3000H memory location, to AL, and DI, the value present in DI, the first letter in DI will be copied to BL, and I am comparing the first two letters. Okay, comparing first two letters. If these are equal, I have written jump no equal. Jump no equal. If it is equal, it will do this. If it is not equal, it will skip. Okay, so if these two first letters are equal, then it will do this job. If they are not equal, see, if one of the letters is not equal to another letter in a sequential manner, that is one letter by letter in a string, then it is not at all palindrome. So it will, if there is a single letter which is not equal to another letter in the reversed string, it will just come out of this loop and it will go to skip one, and it will do, and it will display this message 2, which is nothing but the string is not palindrome. Okay, string is not palindrome. Okay, then if let's say all the if the first letter is true, okay, if first letter both are same, okay, then it will do this job, increment di and increment si, because first letter is same of both the reversed and entered string, it will go to the second letter, increment, and checks. Okay, if all letters are true, it will not display this, okay, because it won't come here. I'll tell you what happens. Then it will come out of this entire loop 2, actually up to, okay, then it will display message 1. Message 1 is says boss your string is palindrome, okay, palindrome it will say, okay. Move ah,09, actually this all three statements, lea dx comma message 1, move ah,09 and in21h, these all three instructions together will display the value. See, whatever the message I want to display, here it is message 1, I have declared it as message 1, as you can see here, message 1. This message 1, its address must be stored in a dx, so as to display this message, okay. So these three statements should be always, it should be stored in dx only. Whenever it is stored, the effective address of this message is stored in dx, then only it can display this message, otherwise it cannot do this, okay. h,09 will tell the string display, okay. And then this jump 1 is written. This is because whenever it says message, whenever it displays message 1, it should not display this also. Actually in 8086 microprocessor, the instructions are executed sequentially. So if I don't write this, let's say I didn't write this, it after executing this, after executing all these statements, it will directly go this and it will display the second message also, that is string is not palindrome. I don't want that to happen. That's why I have written whenever it displays this message, it has to just skip this message. So jump 1 I have written, it will go to 1 here, and it will int 3h's interrupt, which is to suspend the program. It will suspend the program. This is how entire program is done. This is very simple program, because just create two variables, create two messages, and just take one string inside, okay, then reverse the string and compare. There are three loops, very simple loops, all are very similar, and you have to remember all these things very clearly, otherwise you won't get a proper output, okay. Let's see whether this code works or not going into this, okay. Let's see. As you can see, it is telling string is not palindrome. We will check whether the value is stored in memory location or not. In 3000H, the value of whatever we enter, it should be stored as it is, JSDF, it is stored as it is, as you can see this JSDF, and this is what I entered, JSDF, okay. Again, if I see in 2000H, what should be there? The reversed value should be there. See, FDSJ, this is the reversed string which is stored in 2000H, okay. And I will check for one palindrome sequence, okay. Q, G, I should do G for execution, and now I will write madam, which is a palindrome actually, okay. Here it is telling string is palindrome, okay. You can check for those two values, D, TS 3000, madam is stored here, okay, and again D, TS colon 2000, if you see, madam is stored here because both are same. Okay, this is how it works. I'll upload this code into, I'll send the link below in the comment section of this code. You can download the code and try it out by yourself. Thank you.